Hello everybody and welcome back to more of the Cimc, Canadian Intermediate Math Contest from the year 2016. We're looking at question 6 in A part. This is the last question in A part, but as I occasionally remark, I expect it to be harder than the first question in B part. Difference between A and B, of course, A just requires final answer, B part requires justification. Okay, but A6 can often be the second hardest question on the contest, so don't let the fact that it becomes before B1 and B2 lead you to sort of a false sense of security. This can be a challenging question. Alright, so let's take a look here. A line has equation y equals kx, where k is not 0 and k is not -1. Okay. So if we could just for a moment start thinking, what sort of lines are y equals k times x? Well, we should hopefully have knowledge of equations of lines under our belt. And you could probably start drawing some, if you needed to, you could get examples. Y equals 2x, going to shoot up like this. You can get y equals -1/3 x, and that's going to come down here at a more shallow angle. But one of the things to note about all of these is their y-intercept is going to be 0. So that means all of these are going to cross the origin. Okay, you can even see x equals 0, y equals 0 is going to be a point on this line regardless of what k is. So those are the sort of thoughts we start having in our head as soon as we see that equation. Y equals kx, okay, this thing passes through the origin. Alright, so what are we doing with these? The line is reflected in the line with equation x plus y equals 1. So this is an equation of a line in standard form. If you're more comfortable with it, you can rearrange this to be y equals mx plus b. I know that's what a lot of people like. But I'm guessing there might be a reason they gave it to us as x plus y equals 1. We'll see. Determine the slope and the y-intercept of the resulting line in terms of k. So this reflected line, we basically just need y equals mx plus b form. Slope is the m, and the y-intercept is the b. So we need enough for y equals mx plus b. Now, I'm sure there probably are formulas for reflecting this line in this line based on y equals mx plus b, or rearranging everything in standard form. I don't know them off the top of my head. If you do know that sort of thing, you could probably apply it here with a little justification, but we're just going to have to sort of draw some pictures. We know what these y equals kx's look like, and our reflecting line, x plus y equals 1, we can get that pretty quickly as well. And so from there, maybe we can find the intersection point of those lines and do some angle reflection-y stuff. That's what's starting to pop into my head. Okay. So, x plus y equals 1. We only need 2 points to determine a line, and we can see pretty quickly that 1, 0, and 0, 1 are going to lie on this line. Even if you're one of the people who likes to leave a little justification on your Part A questions, so that if you get something wrong, you can still get part marks, you wouldn't have to justify that. You just say 1, 0, 0, 1 are on the line. We're done. So let's use y equals 2x. As our sort of stand-in for y equals kx. Okay, and then this blue line will be our reflecting line. So it's 1, 0, 0, 1, or sorry, 0, 1, 1, 0, anyway. So this line comes down here like that. So we can see that we're going to get an intersection point. Now, do we always get an intersection point regardless of what k is, provided k is not 0 or -1? Things to think about. I think this blue line has a slope of -1, so if we were to have a slope of -1, it would come down like this and never intersect. So, since k is not equal to -1, I think we can safely say we will get an intersection point. Now, if we're reflecting, well, first I want to figure out this intersection point. I don't know if it's going to be useful, but I suspect it will be. So since k is not equal to -1, and like I said, if you want to, you can rearrange this guy so he's in y equals mx plus b form. It'll be -x plus 1 there, because 1 is the intercept, and bring the negative x over to the other side. So since k is not equal to -1, y kx and x plus y equal 1 are not parallel. Therefore, they intersect. Okay, so let's find that intersection. So we know y is equal to kx, and we know x plus y is equal to 1. Well, y is equal to kx, so we got x plus kx is equal to 1, or x times k plus 1 is equal to 1. X is going to be 1 over k plus 1. Another reason you don't want k to be -1, because this would be 1 over 0. Alright, so if that's x, then what's the y coordinate? Well, it's just k times that. Okay. So we know this intersection point. Will that help us in any meaningful way? I don't quite know, but I think it will. And here's what I'm thinking. I'll redraw my picture and label my intercept. So if k is equal to 2, which is the one I was working with there, we'd have the intersection point is 1/2, sorry, no, 1/3, 2/3. Okay, so we'll redraw our lines. So I've got my intersection point here, and it's 1/3, 2/3 if we've got y equals 2x here. Maybe different examples will be needed later on to get a sense of what's happening, but I think this one's fine as is. So now we're going to reflect in this line, the blue line here. So what does it mean to reflect? Okay. Well, if we imagine if we imagine the blue line sort of as a mirror, and our red line or our magenta line is coming in here, we imagine it's a ray of light. It's going to hit the intersection point and bounce off. Same thing with the red light ray coming this way, it's going to bounce off. And we're going to get this nice purple line that is the intersection. Now, one thing we should know about mirrors, since we're treating the blue line as a mirror, is the angle that you come in on is the exact same as the angle you leave on. Okay, so if we could figure out maybe this angle theta between the two, the blue line and the red line we start with, then we'll know the angle between the purple line, our reflected line, and the blue line. And then we should also be able to get this this in here, 100 minus 2 theta. How would that help us exactly? Because we still need the slope, right? And then we'd also need this intercept here. Wow, let's zoom in for a second on our intersection. Maybe this isn't the right way to view it. So the blue line is acting as our mirror. Our red line comes in from somewhere, and we treat it like a reflecting line, so it bounces back in both directions. So we get theta, we get theta, we get a theta, we get a theta. We could also draw in this orange line perpendicular to our blue mirror line. And the purple line is the reflection of the red line in that as well. Well, we know... Okay, I'm just trying to think of ways to get the slope and the intercept. We know this intersection point here, although I guess I've been using green for that. We know that point is 1 over k plus 1, k over k plus 1. If we, for example, knew all the way over here our brand new intercept, then from there we could get the slope. Okay, so that's a nice plan of attack, and it shifts. Now we don't have to deal with what is the slope. We can just ask ourselves, okay, what is that other intercept? I don't know if this is going to be an easier question, and I'm sure that if I knew the slope, I'm pretty sure we can do y equals mx plus b and get the intercept as well. But it's just a question of which do I think is the easiest to work with. Okay, and I don't quite know which one I think is the easiest to work with right now. I'm trying to figure out my plan of attack. Once I've got my plan of attack, I'll do this calculation, this calculation, this calculation, and if my plan was correct, then I'll get my answer. But I'm still trying to work out what should I do rather than actually the calculation. Okay. I think it's got to have something to do with these angles here, but I'm not entirely sure in what way. What does it mean to have an angle theta between these two lines? Well, one thing I haven't been using is that our red line goes through the origin. So maybe that can help us out. As a matter of fact, let's get rid of some of this, and let's just draw the first quadrant. So I got my blue line here, and I'm going to make it fairly big looking. And whatever my red line is, I'm going to assume it intersects at just for convenience, I'm going to assume it intersects somewhere in this range. Of course, different k values will get different intersections, but the math should all still be correct. And I have been using green for this intersection, so put that back. All right. This guy is going to be 45 degrees just because it's 1 and 1. So we got another 45 degrees here. This angle I can probably determine from our choice of k. Now you go over by a certain amount and up by k. Over by 1, up by k, that's how slope works. So I can probably figure out this angle right here, and then from there get this angle here. And then I still need this one here. It's got to be the same theta, but then we have 45 theta and, I don't know, let's call this guy phi for a moment. We'll still get the same phi here. And that phi can be given by over 1, or up by 1 over by k. So I think the slope of the new line is going to be 1 over k. And that would explain why k can't be 0, because then this wouldn't be a slope at all. And that also makes sense, because imagine if I did have my line going horizontally. It would hit this, the blue line, and it would bounce off, and we'd get a straight up line, so you wouldn't be able to get a y-intercept. Okay. So this is all starting to make sense. 1 over k, that's going to be the slope of our new line. And if that's true, y equals mx plus b this. So that's our new line, and then we know 1 over k plus 1 and k over k plus 1 are points on here. So we'd get k over k plus 1 is equal to 1 over k plus 1 plus b. And I can rearrange. I'll flip over to the next page so my calculations aren't so small. So I'll change it to k squared over k times k plus 1 is equal to 1 over k times k plus 1 plus b. So b is going to be equal to k squared minus 1 over k times k plus 1. However, k squared minus 1 can be factored into k minus 1, k plus 1. And then those will cancel out because k plus 1 isn't 0 because k is not negative 1. So my b is k minus 1 over k. So our reflected line has slope 1 over k and intercept k minus 1 over k. Alright, and so in general it looks like y equals 1 over k x plus k minus 1 over k. Okay, now I'm satisfied with that answer. It's an A part, so I don't really need to explain it, but I think I want to go through this in my head one more time. I think that's the answer. I'm pretty sure that's the answer. In which case, you can go on. We'll be doing B1 next. But I'm going to go back, run through the thought process in my head, and I think I'm actually going to compute an example and maybe take a slightly closer look at this. So you're welcome to stick around for that and watch me double check this. If you want to move on, that's fine. Thanks for watching. I'll see you next video. Okay. So let's just go through the reasoning one more time. I know we're treating it like a reflection, so the blue line is essentially a mirror, which means the angle in is equal to the angle out. This is a nice property of light. If you haven't encountered that before, then this is a great way to know about it. It's something that is more covered in a physics class, which is why I'm not going to dwell on it. But angle in is angle out. Okay. Now, if we just look at the specific case of in the first quadrant, we get these nice 45 degrees, which means our whatever that angle is in, it doesn't really matter, but whatever it is, we get we get two similar triangles up here. Now, this angle phi is the same, has got to be the same as this angle phi. Well, the angle phi is the angle you get when you go over 1 and up k, which is the slope of our red line. So how do we get phi? Well, we've got to go over 1 and up k, or we could take this triangle and switch it around so it looks like this, or looks like this, something like that. So, if we're intersecting here, so you might say, well, why? How do you know it doesn't go like this, and you have to actually get the angle to be over k down 1, in which case your slope is negative 1 over k. And I would say, well, that's actually going to give you the right angle between the two. Yeah, that'll give you a right angle. Is there a reason that the purple line should be going up and over and also have a positive slope? Because that's really what would differentiate the two. It can either be up 1 and over k, or over k and down 1. And that one of them gives you a negative slope, one of them gives you a positive slope. And I would say it's clear from the picture that the purple line has to have positive slope. but is there a better reason? I think the only thing I can really say is the negative 1 over k gives us a right angle here, which, depending on our value, depending on our choice of k, you will get an intersection of some theta that's too big to make theta a right angle and then theta again. So it's just not going to work. So we get a slope of 1 over k, rise of 1, run of k. And then once we get that slope, we have the point on here, we solve for it, yada, yada, yada. Okay. That's fine, that's satisfactory. I want to compute an example or two, just really quickly. I swear I clicked that already. There we go. Alright, so based on our theory, if I start with y equals 2x, I will be needing y is equal to 1/2 x plus 1/2. Okay, 2 minus 1 over 2, of course, just 1 over 2. How does that actually look? Okay, so our y equals 2x is here, and then we have, we'll put our blue line back in. And then we want this reflection line, and I'm claiming that that's 1/2 x plus 1/2. Okay, so they both have intersection point. So we were told that the intersection point was, for this one, 1/3, 2/3. So 1/2 of a third is a 1/6, plus another 1/2 is actually 2/3. Same thing with 1/2 of a third times 2 is 2/3. Okay, that's fine, that's clear. And they both have positive slopes. In terms of the angle, we got this angle right here, this angle right here. We know both of these are 45. We're looking at a right angle triangle, 1, 2, and this will be root 5. So this angle is nothing particularly useful, but it's arctan of opposite over adjacent, which is 2. And this angle right here is arctan of, so it goes 1, 2. So it's also going to be tan inverse of 2. That's a single solitary number, so both of these angles are the same, which means these angles of intersection are the same. Let's see how it would look if we had a nice negative slope. And then I'll end the video there. That's not quite accurate enough. We really need more of a 45-degree angle there, so that's a little better. Alright, so I never actually tested how does my theory work when I do something like negative 1/3. So here we got y equals negative 1/3 x. So we do get an intersection point down here, and this intersection point should be 1 over k plus 1. So this should be 1 over 2/3 or 3/2. And then negative 1/3 times that, so negative 1/2. Okay. Those do add up to 1, and yes, those are both. So that is the intersection point. Okay, great. We can check that out. Now my intersection is quite a shallow looking angle, so it'll bounce off like this and go up like this. Where will it intersect? Will it intersect at the top or the bottom? So, okay, trying to figure out without actually resorting to my calculation as to where the intercept will be. Negative 1/3 x should bounce. I think it should be a bit more like this, and it'll be, based on my picture, a very, very low intercept point down there. Maybe a little steeper. Alright, now what does the theory tell me? It should be y equals 1 over k. Well, k in this case is negative 1/3, so negative 3x. And then plus, we're going to have to go back. What was the rest of the theory? K minus 1, so negative 1/3 minus 1, so that's negative 4/3 over negative 1/3. So negative 4/3 over negative 1/3, so it should be plus 4. Oh, so it should intersect some really, really, really high up here. So that was more like the first one I drew. All right. So I still buy that's that's a proper looking reflection right there. Maybe if I drew the picture a little further out. Ah, why can't I draw it tiny? Okay, blue. Negative 1/3, quite shallow, intersects beyond the 1. And then in theory, it should go way, 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 way up. And yeah, that's looking more like a reflection to me. Alright, so I buy that all our theory works out, and it doesn't work out in a bad way. Just, I guess I drew too small a picture, or too focused over here as a picture. But there we go, that's question 6, or rather, that's been question 6, and we've done it for quite some time. I just wanted to go back and check my reasoning. So, that does it for part A on this contest. In part B, we need to actually show our work, so we'll prep for that, and I'll see you guys for question number 1 in the next video. Thanks for watching.